All right, guys. Today we're going to be talking about um, what we're starting with this week. And this week we are going to be exploring uh, the ways of perfect squares and exponents. So if you see here 6.4, the student will recognize and represent patterns with whole number exponents and perfect squares. You can see here understanding the standard is what the SOL will be covering in our essential knowledge and skills. So they will want us to recognize and represent patterns with bases and exponents that are whole numbers. Recognize and represent patterns of perfect squares not to exceed 20 to the squared by using green paper, squared tiles, tables, and calculators. So again, 20 squared. Recognize powers of 10, whole number exponents by examining patterns and place values. So we're going to be talking a lot about perfect squares. What is a perfect square? We can see here, these are some just-in-time quick check that the state has released that kind of help us to prepare for the SOL at the end of the year. As you can see here, there's a lot of patterns involved. So just like your notes say in your modules, if you go back to those, there are 6.4 notes. Anything that's raised, for example, to the 1 power, like 6 to the 1 power, it's always going to be itself. Anything that is squared, like 6 squared, okay, that means that it is a perfect square, okay? So that means if we think about a square shape, it's going to have 6 on all of its sides, so it's why we call it 6 squared, or what it means is 6 times 6, okay? So for that one, for number 2 here that we're looking at, will be 6 times 6. Okay, and then of course we will get 36, and that could go for any number. That could be 7 squared, that can be 8 squared, it can be 9 squared. Whatever it is, you're going to multiply that number twice because it does represent that perfect square. This one here, we have 6 cubed, or 6 raised to the 3rd power. This exponent 3 tells me that my base 6 is going to be multiplied 3 times. Okay, so it's going to be 6 times 6 times 6. All right. Now, if we look here, we have under this number here, we have 6 to the 5th power. So if we didn't know what exactly that was, using your Desmos calculator, which you most certainly can use, this is our Desmos calculator. And with this, what we can do with our calculator, we're going to put in 6. All we have to do is type in our 6, and then we're going to click AB, and then we're going to put to the 5th power there. And you can see that it automatically gives my answer for that. So again, when you are putting exponents in the Desmos calculator, which I have linked in your modules, all you have to do, again, for say, if we were doing, let's even say if we was doing 7, let me get the drawing tool here. Let's say 7 to the 6th power, okay? All I would have to do is click 7, go to my AB key here, click AB, and then click 6, and it automatically gives my answer for that, okay? So again, perfect squares, which you can put them in the calculator, that's not a problem. You know, a perfect square is anything that is squared, that's raised to the 2nd power. You know, we have numbers that are, like we just worked with earlier, that was 6 squared. You know, that's a perfect square. We have numbers that are 3 squared. That's a perfect square. We have numbers that are like 5 squared. Okay, so any number that's squared, that it's, you know, 5 to the 2nd power, 3rd to the 2nd power, those numbers can be put in the calculator as well. If I wanted to put in 5 square, I would type in, I would click 5, and then this A square key right here, which automatically squares it. 3 squared, I'd go over here, clear all, click 3, and then A square key. So that's just a nice little feature to go ahead and square the exponent you're working in. But again, perfect squares are numbers, if you think about a square shape, that would have those same measurements all the way around that makes a perfect square. Okay. But again, for all other exponents, you know, say if we was doing 5 cubed or 5 to the third power, we would hit 5, AB, 3. And then that gives me my answer for that. So those are just a quick explanation of what we'll be working with on exponents, how to type them in the calculator to figure out your answer, and what exactly a perfect square is. Thanks.